Alright, so first I'm going to start off with a chemistry joke. So what is a cat made of? Iron, lithium, and neon. Feline. Oh. Alright, so we're doing table logic, and we're doing 2003, number 3. So for A, they ask us to determine the order of the reaction for each reactant listed below. So for letter I, we're going to use experiments 1 and 2 because the ratio of BrO3 minus is 1 and the ratio of H plus is also 1. So we're going to take the experiments 1 and 2, we're going to find the initial Br in each one, and we're going to ratio them over each other and raise them to the n power, and n is what your order is going to be. Equals, and you're going to set it equal to the rate of disappearance of BrO3 minus. So n equals 1 in this case, and so it is first order. For BrO3 minus, we're going to use experiments 1 and 3 because the Br minus and the H plus are ratios of 1. So we're going to have 0.005 over 0.0075, and raised at the n equals 2.5 times 10 to the negative 4th over 3.75 times 10 to the negative 4th. And n again equals 1, so it is going to be first order in regards to BrO3 minus. For H plus, there is no experiments where the BrO3 minus and the Br minus both equal 1. So we are going to do a complex ratio using experiments 3 and 4. So we're going to say 0.2 over 0.1 for the H plus to the n times 0.015 over 0.0075 for the BrO3 minus equals, and then you don't need to do the Br minus because that is actually a ratio of 1, equals 3.0 times 10 to the negative 3rd over 3.75 times 10 to the negative 4th. N, in this case, would equal 2, so it's second order in regards to H plus. Okay, for B, it asks us to write the rate law for the overall reaction, and the equation for rate is rate equals K times the concentrations raised to the powers of their order. So for this one, rate is equal to K times Br minus to the 1, and I'm going to do the 1 here so you know that's first order, times BrO3 minus to the 1 also, and H plus squared because it's second order. And that's all you have to do. And then for C, you just plug in numbers from one of the experiments and solve for K. So we're going to use experiment 1, and so you plug in the rate of disappearance for the rate is 2.5 times 10 to the negative 4th equals K times 0.001, which is the Br minus raised to the first power, times 0.005 raised to the first power, which is the BrO3 minus, times the 0.1 squared, which is H plus. And K ends up equaling 5.0 times 10 to the 3rd. And its units are 1 over m3 to the 3rd power times s. And that is because the overall order of the reaction is 1 plus 1 plus 2, which equals 4. So it's a fourth order reaction, and those are the units that you use for a fourth order reaction.
Okay, so for D, you're going to have to reference the equation at the top of the page to find the standard cell potential. You don't use your reference packet because it gives you the amount of volts, so that would not come in use, especially because you have BrO3 minus, and that is not on your reference packet. So what you're going to do is you're going to balance these two equations, so you'll add them so they equal the top equation. So for the first equation, we know that we need Br minus on the opposite side. So we're going to have to multiply the whole equation. You can't just move stuff around arbitrarily. So multiply the whole equation, and you know it has to equal 5, but this is 2. So you're going to have to multiply it by 5 halves. So you do that to the whole equation, and what you end up getting is 5 Br minus goes to 5 E minus plus 5 halves, or actually, it would be minus 5 half Br2. And if you look at your second equation, it is BrO3 and BrO3, so there's nothing to worry about, so you can just leave it as it is. So if we add these, so BRO3 minus plus 6H plus 5E minus goes to 1/2 BR2 plus 3H2O. If you add these, everything will end up crossing out to equal this equation. So your 5 electrons go away, your BR2s cancel out with each other, and so you end up getting 5Br minus plus BrO3 minus plus 6H plus goes to 3Br2 plus 3H2O. So you know that you did it right because it balances out. So good job. Okay, so now that you've figured out that the top equation is the equation you have to flip, you make it negative 1.065, and you're going to add the bottom equation just like you added the equations here, so you're adding 1.52. You add these and you get 0.46 volts because volts is your unit, and that is your answers. It's not 0.455 like the equation gives you because of your sig-fig rule, so remember that. Now, when solving D, we also solved E because the total number of electrons canceled out was 5, and so that is your answer, 5 electrons.
All right.